Hello, and welcome to this series about microservices. In this series, we'll split it into playlists that talks about different topics. These topics are related to each other and constitute together a holistic view about how to create or work in a microservices architecture solution. The topics would be containers, microservices, Kubernetes, monitoring, domain-driven design, and clean architecture. The first playlist would be containers, and this episode is talking about containers for everyone. We'll be talking about what does it mean by Docker, what does it mean by a container, and what's the difference between container and a virtual machine. We'll be talking about different concepts that would be useful for everyone. In the next episodes, we'll focus more about why containers are useful for software developers and why containers are useful for DevOps engineers and system admins. First question is, what's the difference between a Docker container and a virtual machine? Let's first talk about virtual machines. Virtual machines, if we think about the lowest layer is the infrastructure, the hardware. We put a host operating system, and then we put a hypervisor. The hypervisor is the software that translates between a host operating system and the guest OS or the virtual machine. It translates things like how to use processor, memory, network, and file systems. And then when we look at the diagram on the left, we see these are three virtual machines, each one containing a guest OS, which is a complete copy of an operating system, including its kernel, its all of the supporting processes, which take a space in the storage, a space in memory, and it consumes lots of CPU. And on top of that, we install bins and libraries, let's say, and the application. Let's say the bins and libraries are, if I'm hosting a web application, I would need a web server. Let's call it Apache or IIS. And then I would need a runtime that fits my programming language. If I'm using .NET, I'll be needing the ASP.NET runtime. Or if I'm using anything, I would need, for example, in Java, I would need the Java SDK or the Java runtime. And then I would be installing my application on top of all of that. And so when we compare this view to the Docker containers view, we see the infrastructure is the same, the host operating system is the same. The Docker daemon process is very similar to the hypervisor. The difference is what we install on top of that. As you see, we don't have, as we have these same three applications hosted in containers, they don't have the guest operating system part, and they don't have any shared libraries or files as well. So in this case, these containers share the same host operating system, they share the same kernel, they don't get a full copy of the operating system. And in this case, we save a lot of storage, a lot of memory, and lots of CPU cycles, because we don't need to run all of that. We only need to run our application and its direct dependencies. And this saves lots of space to allow running more containers on the same server, on the same hardware. And this is the main benefits of using containers. It's a small way to package applications. It allows us to host many more applications on the same server and on the same resources. So it's a cost-saving alternative to virtual machines. It provides the same isolation level that we get from virtual machines. We'll talk about isolation levels in more details. Now let's get to the nitty-gritty details of how containers are working from the inside. It will allow us to understand the main concepts that we need to start working with containers. So let's jump in. The first topic we'll talk about is network. So how Docker daemon process translate network between the host OS and the containers. Let's say we have a host OS, we have a Docker daemon, and we run container one. And this container one contains a web application, as we said. We call it website 1.0. It's version 1 of my website. And this website uses port 80. And when I tell Docker to run my container, I told him to map port 80 to port 80 on the host OS. So in this case, when I type into my browser, I type localhost port 80, it directs me to the same port 80 on inside of the container. Now let's say I want to run container 2 with website 1.1 as this is a new version of the website. I need to run it simultaneously with container 1, and I need to run container 3 with a different version of the website as well. As you can see, all three containers are internally using port 80. They don't realize that port 80 is taken by another process. I didn't have to change my configuration of these containers or of my code or my configuration to link these websites to make them open different ports. But instead, when I told Docker run container 2 and container 3, I told it to map port 8080 to port 80 inside container 2 and port 8090 to port 80 on container 3. In this case, you see there's a level of isolation. These containers, every one of them, think that it's running on its own machine. All of them are opening port 80. This is not doable on a normal environment or a normal setting or in a virtual machine, but it's doable inside a Docker container. So this is how Docker daemon translate different ports from the host to the inside containers. Let's go to a different topic other than network. Let's go talk about CPU and memory. Now we have a host OS. This host OS comes with a kernel and comes with other OS processes that are necessary for this operating system to operate. And then we tell Docker, please start container 1. And container 1, as we said, it's the version 1 of my website. And my website is generally, it's a process. I don't need a different kernel. It will use the same host OS kernel. It will just start a new process. Think of it as this is process 1 of website 1. When I tell Docker start a new process for container 2, it will start a process 2 for container 2. When I tell it start container 3, let's say in this case, container 3 contains 2 processes. A container is not associated with a single process. It's a level of isolation as we spoken earlier. So in this case, process 3 and process 4 process 3 is the website, process 4 is a background agent that runs in the background. It's a different process, but both of them shares the same space. They use the same file system, they use the same network. They cannot use the same port in network because they are in the same container. To the operating system, these are just different processes. They don't take up much of the memory. We only need the memory that are needed by these processes. And in order to do this, on Linux, we use a feature called cgroups and namespaces. These features were available in Linux a long time ago. They were very handsomely utilized by Docker and by containers to create a level of isolation that these processes runs into their own namespace. They're using cgroups to isolate them in terms of the user access level that they get. And they use as little as these processes need of CPU and memory. We are not replicating the kernel. We're not replicating any other processes that are not needed by these containers. Let's go to the next topic. The next topic is about file system, how these containers coexist accessing the same file system. So Docker daemon is in the middle. It translates between the physical file system and the logical or virtual file system that these containers need. And then let's talk about concept of layers. What do we mean by a layer? A layer is a file system layer that contains multiple files. So let's say I need to create a container. My container is a web application, as we spoke, and this web application would need a Linux version. So we download a Linux image. Let's say in this case, it's a 50 megabytes. This is just an example. So this is a layer containing a base image of Linux. And then I add another layer that is for ASP.NET runtime. This is ASP.NET runtime. It acts as the web server. It acts as the runtime needed for a .NET application to operate. And this runtime, let's say, for the sake of example, it takes 20 megabytes of file system, of storage, of space. And it depends on the files existing on the below layer, the Linux image. So when I download ASP.NET 5, it will download this 20 megabytes and it will download, it's dependent on the 50 megabytes of this Linux image. And then I create a third layer that has the files needed to host my website. So let's say my website is composed of HTML files, CSS files, JavaScript files, and images. And I host, and these files are 10 megabytes of space, of size. And I create a third layer. It's called my website files. Until this point, I consumed 80 megabytes of storage. Now, once I tell Docker, please run this container for me, create container one. Before I created container one, this was just an image. When I start container one, now container one is running in the memory, it's using the CPU. When it tries to access the file system, it talks to the file system through the Docker daemon. The Docker daemon tries to fetch whatever file it's trying to access. Let's say it's trying to access a file from the operating system. Docker daemon will direct this request to fetch a file from this below lowest Linux image layer. If it tries to access file from ASP.NET, it will access the second layer. If it tries to access file of my website, it will direct it to the third layer. And as you see, there is a thin read-write layer created on top of that. These are read-write. Everything below is read-only layers. We fetch files from it, but we don't write to it. Anything that we write, for example, for this case, my website writes log files for its operation. Any log files will be written to this thin read-write layer. And this layer is considered a temp layer that I need during the runtime, during the execution of my container. Once I don't need this container anymore, I will kill this container and I will kill this layer. Let's say I need to start container 2. And for container 2, I created version 1.1 of my website files. This is a new version of the files that takes and another 10 megabytes of space. But as you can see, they are using the same layers below. So I will not duplicate the 20 megabytes for ASP.NET. I will not duplicate the 50 megabytes of Linux image. And in this case, I'm only creating an extra 10 megabyte layer. And I'll tell Docker, start this container. And as you can see, it starts the container. It creates a thin read-write layer, exactly like we did with container one. Now, another example is, let's say I want to run this website 1.1. I want to have 2 instances of this website. I want to try running in a parallel environment or something like that. So I'll tell Docker, please use the same image from version 1.1 and create a new container. This means I'm creating container 3 for the same version, for the same image. It is reusing the same layers. It didn't add anything extra to the storage other than the thin read-write layer, which is 0 size until we start writing to it. So as you can see, Docker or containers in general are very efficient in using the file system storage. It is reusing whatever files that we can reuse from other images. Now that we know what do we mean by layers and file system, let's identify when we created this container images. Let's forget about the runtime of the container. Let's forget about how the containers are starting and running in memory and in CPU. And for now, we will talk about how to create an image for this container, how to create an image that allows me to start many containers out of these images. So in this case, we take our layers. And let's say we start, when we want to create the image for our website, we start by downloading the ASP.NET 5 image. And in this case, this image is called ASP.NET. The colon in the middle identifies the difference between an image and a tag. Anything after the colon is the tag. So 5.0 is the tag. It's basically here identifying the version of ASP.NET that I want to download. An image can have one name, but it can have many tags. And as you can see, there's another line here that says, this is the long version of the image name. It's mcr.microsoft.com/.net/ASP.NET. This is the full image name, which identifies from where do we download this image. Let's say now I need to create my website. I tell Docker, please pull this image from online. It will download, and in this case, it will download the 20 megabytes of ASP.NET, and it will download any dependent layer like the Linux image, which is a layer of 50 megabytes. It will download all of these layers needed. And then I'll create a new layer. I'll copy the files of my website into this image. And then I'll tell Docker, please create a new image and call it my website. And I'll give it the tag 1.0. In this case, we created an image. A tag is a pointer that points to this image. And that's it. Now we have an image that I can start containers out of. Let's say I want to create 1.1 for now. So 1.1 has the same image name, my website, and it has the tag 1.1. Another thing to know about tags, I can assign multiple tags to an image, and by default, by convention, the latest version of an image usually takes the tag latest. So the same image here that has 1.1 tag, it can have the same another tag called latest. And by convention, we know that this is the latest image. And also, when we tell Docker, please download my website, and I didn't specify a tag, it automatically tries to download the tag with the name latest. If I created version 2 for my website right now and uploaded it to a registry, this new image by default will take the tag latest. I said the word registry, so let's go see what do we mean by registry. As we spoke right now, when we identified how to create an image from my website, this image I downloaded the images from a registry, and I created this image locally, and I can push my image, my new image, and my new versions of the same image to a registry. So a registry is a space, a server where we store images with different versions, container images. We call that container registry, and the most popular one called Docker Hub. Let me show you what Docker Hub looks like. Docker Hub is a website called hub.docker.com. You can register, create an account for free, and it will allow you, if you go to explore, this is the 8 million available images that are in this registry. So this is the most popular container registry. Any open source solution, you will find them publish their images to this registry. If you need any version of or any runtime or any server, any database, you will find container images in this registry that are related to that. For example, let's see Node. In this example, this is the Node container image. This is the image. It has many tags. This is the command line that you need to write in order to download the latest version of Node, Docker pull Node. If I click and view available tags, it will show me all the tags that I can use to download Node. Now, let's go to, if I want to start this on my local PC, how can I start using Docker? In this case, I'll point you to Docker Desktop. Docker Desktop is the most common application that I can use as a user, as a developer, as anyone. I can download it into Windows, Mac, or Linux. Um, it will allow me to start pulling images from Docker Hub, pulling images from anywhere, um, creating new images, starting containers. And by the way, when I create my own images, I can publish them to Docker Hub if I want it to be public for everyone, or in other cases, if I want these images to be available only to my solution in my network, I can create a version of a container registry. It's a server. It can be a virtual machine. It can be a container on it by itself, and I can host it anywhere I want. I can configure it to be available for anyone, or I can configure it to be using an authentication. So by that, I want to conclude today's episode. We talked about Docker, how to make use of Docker. The next episode, we'll talk about why containers are useful specifically to software developers, and how me as a developer, I can use it to as my main development machine. I can use it for development, and I can use it to build my application. I can use it to package my application as image to be easily redistributed to others. Thank you very much. I hope this episode is useful. Please like, share, and subscribe to this channel if you want to receive more videos. Thank you very much. Have a nice day.